Hi folks, this is the second lesson of your geometry unit. If you haven't figured it out yet, your answer key isn't in each lesson. It's near the back. It's near the back. So if you're looking for the answer key for assignments 1, 2, 3, it's in the back. Okay, so today we're moving on to interior angles and central angles. Okay, so an interior angle is an angle that's inside a closed shape. Interior, inside. So, an angle inside a closed shape. So if we just look at the pretty picture to the right, there's all kinds of angles. So the exterior angle is the one outside the shape, that's 150, and the one that's inside the closed shape of the triangle, that's what that's called, is 30 degrees. Okay, so we have some mathy stuff to do. So if we want to find the sum of the interior angles, so what do all the angles inside add up to? The sum is equal to 180, and that n represents side lengths again, minus 2, okay? And if you want to know the size of the interior angle, it's going to be the size m, the measure of the angle, is 180 bracket n minus 2, where n is your number of sides, divided by the number of sides. Now, we would do this when it is a regular, when it's a regular polygon. And if you remember what regular means, that means that all of our sides are the same. So we would use this in a regular polygon. Regular polygon. Okay, and for this lesson, super important, you remember your units of measure. Units of measure, and when we're dealing with angles, the units of measure is degrees. And you guys all know what that looks like, 30 degree. You need that degree symbol because if we're using a different type to measure angles with, which you guys don't, it is, it would mean that it's a different type of angle, which you guys don't want. Sorry, my brain left me for a moment there. Okay, so we have to find the third interior angle of the triangle. For example, number 1. So the first thing we're going to do is we're going to find, well, how much do all my angles equal? So find the sum of the interior angles first. Just zooming in just a little bit closer. These examples are kind of small. All right, so if we do this, we have a 3-sided figure. So we know that n is equal to 3, and we're going to use the formula sum is equal to 180, 3 minus 2. And so the sum is equal to 180 times 1. So we know that the sum is 180 degrees. And most of you know that, and I think we did that in our trig unit. The sum of all interior angles of a triangle is 180. So that doesn't answer the question, but now we have the ability to answer it, now that we know that the sum is 180. So we're going to take our 180, and we're going to minus what we know. So we're going to minus 105, and we're going to minus 29. And we're going to see what's left over. So 46 degrees is that missing angle right there. Okay, all right. Things are starting to come together now. Okay, so this one, not a triangle anymore. So first thing I'm going to do is I'm going to sum my interior angles. And we have a four-sided figure, 1, 2, 3, 4. So we're going to have S equals 180, 4 minus 2, and that's just the formula, right? So 180 times 2, which is 360. All right, then all we do is we line them up again. We say, okay, we had 360, and I'm going to subtract the angles I know. So I'm going to subtract 113, I'm going to subtract 51, and I'm going to subtract 82. And what's left over is 114 degrees. Now, you cannot assume that these diagrams are drawn to scale. So you're like, Scallion, that doesn't look like 114 degrees. I appreciate that, I acknowledge that, but keep in mind it's sometimes hard to represent an actual angle in a computer drawing. Okay, so this one's a little weird of a shape. So this one says a pentagon. Well, it also gives us the shape here. So a pentagon we know has 5 sides. So n is equal to 5. So 1, 2, 3, 4, 5. Okay, true story, it has 5 sides. Sorry, I didn't slide up there. I got papers going everywhere. All right, so first thing I'm going to do is I'm going to do the sum. And so S equals 180 times 5 minus 2. So 180 times 3, and that gives us 540 degrees. And so once we know the sum, then we can take away what we know. So we've got 540. And this only works if we're missing one angle. If we're missing more than one angle, then we've got to find a different strategy. So minus 58, minus 100, minus 112, minus 25. Didn't leave myself much room. So that's going to leave me with 245 degrees. So that angle right there is 245 degrees. So I need to make sure my degree symbol is attached to all of these. Okay, so this is another type of question you're going to get for the next one. Find the sum of the interior angles of a regular hexagon. So this one we don't have a picture, but we need to know something about a hexagon. And again, that comes back from lesson 1. So I have 6 sides in a hexagon. So sum is equal to 180, 6 minus 2. So sum equals 180 times 4. So the sum is 720 degrees. So sometimes I might ask for a specific angle, sometimes I just might ask for a sum. Okay. So now it says calculate the size of each interior angle in a regular octagon. So all sides they're all the same length, and we know in an octagon we have 8 sides. I hope you guys aren't writing big. There's not a ton of room. I realize I probably should space this out a little more. Okay. So we're going to use that other formula, the size of each interior angle. So that formula is m equals 180 minus 8 minus 2. That looks really familiar. That's the sum formula. But then we're going to divide by 8. So m is equal to 180 times 6, divide by 2. So m is equal to 1,080. Oh no, not divided by 2. Divide by 8, everybody. Sorry. I don't know what I was doing. I was off in La La Land. So m is equal to 135 degrees. So each angle inside a regular octagon is 135 degrees. Okay, pretty exciting stuff. I prefer this lesson because it's less remembering and more math. But yeah, so you want to make sure that these formulas are on your cheat sheet and that you know when to use what. Okay, next page. Okay. Sorry, I got paper stuck everywhere. Okay, a central angle is made at the center of the polygon by any two adjacent vertices of the polygon. And remember, vertices just mean corner. So those two, and then you meet at the center. Okay, pretty straightforward. All central angles will add up to 360. So the measure of the angle is 360 divided by however many sides. Pretty straightforward. So here we go. So determine the measure of a central angle of a regular quadrilateral. Quadrilateral has 4 sides. So our central angle is equal to 360 divided by 4. So our central angle is 90 degrees. So if I drew you a pretty picture, and remember that it's a regular, so that means all sides are the same. All sides are equal in length. So if it's a regular quadrilateral, really it's a square. If I put a center on that, right? So that's kind of what it would look like. We're looking for this. So this would be a 90. Oh, geez. Sorry, guys, you can't see that. I'm drawing pretty pictures and everything. So this angle here would be 90 degrees. Okay. Determine the measure of the central angle of a regular decagon. So decagon has 10 sides. Regular means they're all the same. So the central angle is equal to 360 divided by 10. So the central angle is 36 degrees. And I'm not going to draw you a decagon because it would be sad. And it definitely wouldn't be regular. It wouldn't have all sides the same. Okay. So those are like the straightforward ones where you plunk them in. And now this last question is kind of like a thinking question. You got to apply your knowledge here. So if a regular polygon has a central angle, it's telling us what the central angle is of 45 degrees. How many sides does it have? So we're trying to find n this time. So we're trying to find n. We don't know what n is. So our formula is central angle equals 360 divided by n. We're trying to find this time. We know the central angle. So we have 45 equals 360 divided by n. Okay, so easy peasy, right? Easy peasy. I don't want n on the bottom. I want to get rid of that. So I'm going to times this side by n because this is divide by n. So if I times it by n, those will cancel each other out. But if I times this side by n, I have to times this side by n. So those are gone. So I have 360 equals n times 45. Look at that. I switched the brackets. I had the brackets around the n, and this time I put them around the 45. Doesn't really matter. I want to get n by itself. So if these two things are multiplied, opposite to that is to divide. If I divide this side by 45, I have to divide this side by 45. So n is equal to 8. Those will cancel each other out. Okay, so here's the thing. This should always be a whole number. And the reason why it should always be a whole number is because we can't have part of a side. If we have part of a side, then it's not regular anymore, and it's probably not a closed object. So if you get 8.27 here, something's gone wrong in your math. You should go back and check it, okay? So that's it for this lesson. Pause the video when you need to. Go back and rewatch it. It's already posted on YouTube for you. So if you have any questions, ask the person filling in for me. If you're not sure, ask Miss Krentz, Miss Thompson, or Mr. Switzer. They'll totally be able to help you. Miss Bellier next door will be able to help you. So if you need something, reach out to somebody. Or look at the answer key, talk to each other, help each other out. You guys are your best resources. I promise we'll see you soon.